Okay, let me get over here. All right, so if you are up in space, here's good old Buzz Aldrin. He just passed away not too long ago. And Cerna was the last astronaut passed in 1980. He was 82 years old. One of the first ones to walk, last people to walk on the moon. So if you're up in space and you're 100 kilograms, what is the mass on the moon? Okay. The moon pulls with 1/6 the force on Earth. Does that mean you've got 1/6 your mass? There's a big difference between mass and weight. Okay? Your weight will be a lot less, but your mass, how many particles you're made up of, has not changed. Okay? The unit of time that we use is the second. That's the primary SI units that we call them, and then the meter. Okay, is the other one. All right, so those are our basic units: is the kilogram, the meter, and now most all of the primary things used in physics are what are known as conceptual. I mean, how far now a meter is measured. It used to be measured, defined as the distance between was the length of this bar, which was mainly defined by the distance from the North Pole through Greenwich, England, down to the equator, and dividing that up into a million pieces, and that's where you got the meter. Okay, but that has since changed because you need to base it on a concept, because this guy will change. He'll either grow or shrink, erode, or something like. So it's got to be based on a concept. And so we figured out that a meter is actually how far light will travel within this amount of time. Okay, so we've got a good idea of the meter. The second, on the other hand, is defined in terms. It used to be in terms how the Earth moved around, but the Earth wobbles and is unstable, and it's actually slowing down in its orbit around the sun. So now it's based on an atomic clock and the amount of radiations, the amount of oscillations that the atoms go through in there. If it goes through 9 billion oscillations, the amount of time it takes to do 9 billion oscillations, we call that a second. And then we keep track of that. And that's a perfect second. Now, we don't have anything for the kilogram. We just have this. And so I'm going to end this intro part with this last little video. It's very interesting on this very object right here. Okay, and then we'll look at conversions. I'll start up tomorrow as we'll look at the conversions and things like that. Okay, but about 2 or 3 of your, or 4 or 5 of your homework questions from homework 1 have already been answered so far. All right, but we'll take a look at what this guy means right now in this next video. And it's really cool. I know it's going to appear long. It's like 11 minutes, but hang in there. It's really good.